In progress.
I'm going to record. Now, when you open My Documents, Documents folder, so in that folder, you see a folder called Protadata. So if you're looking for product that you work on structure, then you can change this one shape. You get it in documents, you get that folder, then all your products. But open Protadata, I have all the projects I've worked on within this folder. So if in case I need to transfer, like open one of the projects I've worked on in your computer, I'll just get one of these folders, let's say this apartments. I share it with you and paste it in the same documents folder. Then you can be able to open it in your computer. Yes. So that is the project folder for Protastructure. Now, let's open Protastructure. Actually, before you open Protastructure, let's look at the that's file folder which I shared with you. There's a CAD file. Open AutoCAD. You open it. Okay, now you'll be given a file like this from the architect. It is going to have several components. You have drainage plans, you have location, all those things. So what for you are interested in is floor plans and cross section. That's elevation views for just reference. So when you get that file, look at the arrangement of the floors. When we are designing a solid structure, we look at the first suspended floor, which is the first floor. So look out for the first floor plan. In that CAD file, it has been arranged in order. So you look at the first floor plan. When you get your project, you will not be arranged like this. So you need to take initiative and ask the architect to give you a CAD file for the project. If not, they will give you the PDF and then convert that PDF into CAD. Because most of the measurements that you will need are not indicated on the architectural drawing. So if you have CAD, it is very easy for you to get those measurements on your own. So you get that CAD file and align that project very well. Like you arrange it in a way that when you are positioning your structural elements, they do not conflict. Lower levels and upper levels are not conflicting, or they are not affected in the position of the columns. Okay, so from what we have there, this is its a PDF file. So in this PDF file, I'll first look at the perspectives of this project. I'll see that maybe it is a 5-story solid structure. I'll look at the elevations of that project. It is having some unique features, like some parts are cantilevered, there are no columns. Okay, when you look at it from here, it has some slabs, of which these balconies, they do not have beams below. Okay, it is a slab, but without a beam below. Okay, so for you, if you design and then place a beam below this slab, you're affecting the money's architectural impression of beauty. Okay, so you need to take that into consideration. Then you look at some of the unique features in the most especially at the top. If there are some water tanks, if it has a lift shaft, if the project has a lift shaft, how do you plan to end the arrangement of your structural elements above? Okay, so you need when you are planning, you need to put in mind the roof, how it will be supported. Okay, so you look at the if I look at the floor plan here, some of the unique features on this project is the staircase area. You have balconies, okay, balconies which are cantilevered, and then you also have at the top you have a terrace. Okay, so as you are arranging your supporting system, you need to now put into considerations that some supports will be terminated down and then others will have to continue. Okay, so after identifying that, now you can think of Okay, you know which areas you're going to design using Revit slabs, know which areas you're going to design using Solid slabs. Okay, so Revit slabs, we put them in enclosed areas. But then Revit slabs, we put them in enclosed areas, and those areas, they should have less, okay, there shouldn't be a lot of moisture in those rooms. Like areas for washrooms, areas like balconies, terraces, we use solid slabs because the rib slabs are not that good in sustaining conditions of water. In case there is seepage, it will create some weak points in the slab. You get it? Also, you need to look at the functionality of the building. If the building it has some parts where it maybe some parts are dancing halls. Okay, so those areas you're going to experience a lot of vibrations. So ribbed slabs, they are not good at sustaining vibration, excessive vibrations. So you can consider adding solid slabs in those partitions. Yes. Then you, after identifying that, now you come and make a scheme of your structural elements using the first floor plan. When we are designing slabs, we don't design for the ground floor slab. Unless that ground floor slab, there's a basement below. If there's a basement below, then you design that slab. But if it is going to be a slab on grade, where you find that you are putting hardcore, you're putting oversight concrete, you're putting BRC, there we don't design that slab. So we start with the first floor. You're going to create a layer in the layer properties. So under home, you click on layer properties and then create a new layer. Now, this part, the first part, this has already been prepared. But now, I'm taking you through about like in the initial stages, which you go through to prepare what you're going to use in ProtaStructure. So now, for now, this one you can observe, okay? Observe, then you review in the recording in your own free time. Once we have reached ProtaStructure stage, we are going to move systematically together. So because now this is entirely AutoCAD work, which you're going to be doing the other side. Okay. So we start with preparing the structure scheme. And with that, you first create 2 layers, actually 3 layers. One layer is going to be for grids, the other layer is going to be for columns, and the other layer is going to be for beams. Okay, so under home, in the layer properties, I'll click on this option, create a new layer. New layer, I'll call it, I'll just give it a prefix which I can easily identify. Structure, let's say grids. Then I'll create another layer, I'll call it structure columns. Then another layer, I'll call it structure beams. Okay, so why I've given them the same prefix is for them to be in the same location among my layers. I don't want to struggle to look for like unique names among this list. So once I give them the same prefix, they will be arranged this at the same position, in that when I'm looking for structural beams, structural columns, it is very easy. Okay, so after creating those layers, we now, I'll start with positioning the columns. So you're going to create a rectangle. I'll click on the rectangle. Click on rectangle, and then first draw it aside. Let's say here, my walls are 200 by 200 thick. So the first property of your columns should be 200 by 200. If your walls are 230 by 230 or 230 thick, your columns are going to be 230 by 230. If your walls are 150 mm thick, your columns are going to be 200 by 200. There is a limit. We don't go below 200. It is better you have a bigger column which meets the wall, a bigger column which is met by the wall, than having a bigger wall which is meeting on a smaller column. You get it? So let's have 200 now. I'll press tab by 200. I'll create this. It should be a restricted rectangle. Then after that, we select this rectangle. We click here where there's this drop down. Remember, we have already created our layer, so the layer is there. So I'll click here and put that rectangle in a layer called structure column. And I can now even make it's a bit thicker and give it a big thickness just to easily identify it. And some color, let's say this color. In that if I place it somewhere, I can easily see it. So now after you have created it, there is no need of hatching. If you want, you can hatch it, but then you realize later on you shall need to delete those hatches, because what we are exporting shouldn't be having hatches there. Okay, in case you have hatched it just for ease of identification, you need to make sure that those hatches, you delete them after. So I don't want to do that double work again. So I'm going to do the hatching. Now I'll get this column and copy it. So when you select it like that, you can use this copy from this point. And now we start your column positioning. So if I place this column, we start with identifying the core positions, and that is corners of the building. I can place the column here. Let me just turn off this. I can place the column here and place another one here. I'll place another one here. Another one at this point, or this point. I'm also confused here. This up here, here, we place here. Okay. So there. Okay. Then down here, can place it here. Okay. This other side. This one. This around here. Okay. Okay. And then here. Here. Okay. Here. Around at this point. Okay. Then in this corner. Okay. Then here. About this part here. This corner. Okay. Then here or here. This one. Okay. Here. That is true. Even here. Okay. Then one here. And another one here. Okay. This one, yeah, it can make a point load. Then you can have here. This other side. This one here. Okay. Then how about this part? I think we can put one here. Then here and here. Okay. Then also here. Another one here. Then also here and here. Then here. Okay. And also here. And another one here. Okay. For the staircase at this point and this point. Okay, so and at this point here, I think let's also have here. I think that's it. But now we need an extra support around here. At this point, yeah. So you can have here and here. Likewise, this other side. And have here and also here. So me, I'm just placing them, but we need to be accurate. They should be aligned with these walls. Yes. So I think now our column positioning is done. It's okay. So once you have finished to place these columns, delete this one. I need to select this, right click, and select similar. Yes, select similar. You select one of them, right click, select similar. To select all of them. If I select one, I right click and I choose select similar. All of them, all the columns, and it's identifying them uniquely because they are on a separate layer. Yeah. So why I'm selecting similar is you copy using this option. You copy like from this point, you superimpose them onto upper levels. Put them onto upper levels and check that there is no conflict. Add them there, add them here, add them here. Okay. And also add them here. That's the roof. Now, you check, you look at them. This one, it will be terminated. This one is slightly off. But then, if we check where it is, that means that the architect needs to revise the position of this wall. Because where it is, it's just where we have the staircase. Yeah. Oh, I'm not saying very well. We can add a construction line. Confirm. Under draw, click on construction line. Make it vertical to cross through this column. Its center. So this construction line, let me make it just for its visibility, and I make it, let's say, yellow. So this column which is off on this wall, I need to inspect it on the lower levels. It is around here, meaning I would have added this column, which is around there. So if I get this and I move it, type move and I place it in line with this, what is the effect on other levels? So when I move it to that point, here it will be okay because it is in the wall. But then if I check here, it is also okay. If I check on the other, it is also okay here. Then down here, it will be okay. Okay. So how about on the last level? The last level to be here. It will also still be okay because this is a gutter. This is a gutter, and I'm seeing these are outlines of a parapet wall. So it can still run through here. So the purpose of you aligning these plans very like together is just for that. So before you start, you confirm the actual positions, follow them up to the last level of the structure. Now, after correcting that, you go now to this first floor and adjust and confirm that this column here, it should be at this point. Then you look out for another one, which is off. So I'll go to the terrace level, check. Is this one. Now this one is where we have the roof terrace. So at this point, this column is not continuing. It is ending at that level. For it is okay. Yeah, because you will terminate it. Then what in most cases brings issues is the last level here, how it is ending. So we have agreed this one, we have shifted it to this position. It's okay. Then is this is okay. This is okay. This is okay. This is okay. But then when we check here, at this point, this column is not there because right around here, we have a terrace. We have a terrace. It is this column here, I think. It is this one. So this one, it will be terminated at this point, and it will have a parapet wall here. So therefore, this column is okay. However much it's misplaced, it's not there. It will be terminated. Then now when we check here, we check at this point, there is no column, but in the end, we have a covering, and here it's creating a big cantilever around here. So if we decide to place, let's say, a column here, if I copy and place a column around here, and just mark it to be different. So this column, if I move along this grid, it should be the column around this point. It should be here. If you look at its position along this grid, it should be here. In line with this one, you see it. It is in the same grid. So I would have added the column at this point, like that. Also, if I go still up, but then when I go up, there's a window. You see now the limitation. So that rules out that column. Now I can now think about, since I cannot add the column there, I'm at the last level. Do we have a wall here? Yeah, like, do we have a wall here at the roof? Okay, is this roof being added onto a wall? We have a wall here, down. So since it is the last level, I can factor in that before casting those beams, yes, the ring beams, you will first have walls. Then the walls will support that beam. You get it? Yeah. So, but if it was at an intermediate level, that would not work. That would not work because yes, the loads, and it is still continuing. But then these are just ring beams just for roofing. The loads are not that much. You get it? So it is okay. But there is a reason as to why. You get it? Yeah. So our column placement is okay. Now we go to beams now. Still at beams, we are going to create a rectangle. I'll call a rectangle. Can we where you can remove those ones, chairs, the doors, if you don't want, because it seems to be crowded. Actually, we don't want those chairs and tables and all that. But then why we need them at this point is to see functionality when we are placing. After we have seen the functionality and placed our items very well, that's why we place them on unique layers. It will be very easy for us to isolate them out and delete the rest which we don't need. Exactly. Exactly. So for example, like now you see this is the sitting room and the dining. Now, when you're placing beams, you may find that they don't need drop beams. So how are you going to know that which exact place where do they need drop beams? It is this the sitting room and the dining. So we first leave them there. Since we have our layers unique, it will be very easy to delete them. So now we will create beams. I'll still call a rectangle. I'll first draw it aside around there. Then I'll select it, put it on that layer which we created first. I'll go to structural beams. Then I'll put it on this color, which I can easily identify. Make it this big. Then I can copy it from this point and I add it around there. So then I can use this to position it that I need a beam from that point up to this point. So here you may not be when you are assigning beams, you don't have to be accurate. We are now looking after where the beams are, because at the stage of working in Proto, we shall not have beams there. Yes, beams we shall recreate them in Proto structure, but putting them here will help us in aligning which beam connects to which support, which beam connects to which support. So there, you may not be so perfect. Yeah. So I have this beam connecting from this support to this support. Then I'll select this one, copy it. I'll move it. I also need to place a beam here. Then it ends here and it connects, it goes all the way up to this support. Then I can have another one connecting from here up to first create one which is horizontal. It connects up to there. It goes up to here. Then I'll have another one connecting around here. Then this one should be the same up to this support. Then I'll have another one connecting from there to there. Now create this one, drop it down up to here, and I'll connect it there. Then get this one, copy it from that point. Then to that point, I'll have another one. CO is the shortcut for copy. CO enter. Then I'll place it from this point. I'll add it to connect to there. Then this one I can continue. I'm making them separate because I want to introduce the slab beam there. So this one can end up to there. And then this one, we can just show that it's quite a bit bigger, because the slab beam has a bigger width compared to its depth. So I can create a unique color to show that it's a slab beam. Then continue to place CO, enter. You don't want to do it there. So you continue to do this and add wherever you have your beams, all this other side. Okay, so I may not do for all. Okay, so I'll keep it at that. Now, after that, we need another layer for grids. Why we need that layer is to give us the center-to-center dimensions of our structural elements. We can use these same grids which came with the architecture. Or you can create like another line to represent the grid, but you should make sure that it is in the center of the support. Columns and grids must be accurate. So now what I'm going to do here is I'm just going to convert these column lines. So these grid lines which came with the architecture into our structural grids. So I'll select them, select this one, and put them on a layer called structural grids. Okay. Then after that, we can get this out. Copy it aside. After copying it aside, we click one beam, we select one beam, we select one column, okay? We select one grid. There are three, one column, one beam, one grid. Then we select similar, like we did. You right click, select similar. It will select all the components that you want, only the three. Then you right click and isolate. Isolate. Now we hide objects. We are hiding what we have selected, our unique ones. We remain with those ones which we want to delete. First, hide selected. And then we select everything here, delete it. Remember, we have deleted this, but we still have the original. That's why we first put it aside. Yes. Now, after deleting, you can still right click and isolate. Now we end object isolation to bring back what we had deleted. See that? You select what you want. First isolate, hide them. What you're left with, delete all of them at once. Then you right click again, isolate, end object isolation. Or else, if it is this one that we have worked on, we can select what we want only. Right click, select similar, and then with them selected, we just copy them, copy and move them aside, and leave them the way they are, but then you also get a copy when they are already organized. Yeah. So the isolation helps a lot. So now, remember I said we do not need these beams there for what we are going to take into product structure. No, beams will recreate them. but we shall be basing on now this one, which on see which supports connects to which one. It is better that way. However much you can also import them, but there is some abnormalities which come with it with that. Yeah, I don't always recommend to. It's just better to read. You delete them from product structure. Yeah, it is okay. It is okay. So now you have this. That is columns and center. So that is what you need to work with data structure. No dimension. And these lines, they should be complete lines. Complete lines, not having a line which is split here and then you continue it when it is split. No, it should be complete line like that. These must be polylines or rectangles, closed loops. Yes. So now, how do we take it into proto structure? It should be in a format that can be understood by proto structure. It's called a DXF file. It's a DXF file. So out of our card which we have prepared, you create a DXF. It's called a DXF file. Okay. So to get the DXF file, we click on, we say DXF out. Type on the command line DXF out. Then press enter to take you to the dialog box. In this dialog box, we choose tools, options, then DXF options, selected objects. Okay. You give it a name and where you're saving. Okay, just like you're saving any other project file. It can be on the desktop or anywhere. So you give it a file name. I'll call it, let's say, proto file. Proto file. Then after that, you click on save. It doesn't end there. You end by selecting what you want to convert. Then press enter. Once you press enter, when you go to that folder where you saved it, you'll see the proto file. So this is the file that you need to take into proto structure. Okay. Yeah. So now we are going to use this file that I've prepared. It's not accurate, but it's not accurate. Yeah. But then there's one which is already there, which is accurate. So it is called DXF file GAD. You have it there. So it's the one which we are going to use. Okay. So you open proto structure. The proto structure that we are using is going to be this one. Okay. So I'll open it, double click. Okay. We are there. We are there. Eh? So we use that one. We use that. So the other one, shall use it to get. Okay. Now. So let's create a new project. Okay. So to create a new project, you click on new project. Put the project code. It's going to be March training. You can give it any file name. Or CAD training. Okay. Okay. So when you're putting this project code, don't put a space. It should be one complete word. Yes. So now then you choose a template code. No, you see all those codes which are there. Those are template codes. Okay. So which code are you using for design? Yes. You want BS? Okay. So we use, click on BS, UK BS, and then click on OK. Okay. Now, I want to give you two methods of starting a project in data structure. You will choose which one which is easier for you. The first method is using a DXF file. We just come to building setout and click on this building setout. And then click on building setout. While you are on story one, do you see in the structure tree here? The stories. Which one among them is bold? Mm. Under stories. The story 0 and story 1. ST0 and ST1. You go down there. ST0, ST1, and ST. So which one is bold? ST1. That means that whatever you are importing is on story 1. Okay. So when you are importing your DXF file, you make sure that it is on story 1. Okay. So proceed. Now, under building setout, you click on the external reference drawing. External reference drawing. Are you in the building setout? Yeah. Then you external reference drawing is here. Click on it. Then you click on add. Then you go to that folder and look for that DXF file. Protect DXF file. You have opened it. Okay, so let's click on import. You have grid. Column is not ticked. So if in case you need to import columns, you must first tick it. But then here it's telling us we need to first assign a layer. So you click under here where the line of that column. You choose structure column. Yes. Choose STRL column. Then OK. After that, we click on import. You can close. Then So you can see how much time whatever you did yesterday is very easy. So, but at times, you would want to, for some small projects, you may not go into AutoCAD, assuming that the center dimensions are so direct. You may not go into AutoCAD and then do all that. You can come straight away into Portal Structure. Like for example, here, you click on modeling. Click on modeling. Click on modeling tab. It is here. It is here. Then you click on orthogonal axis generator. Orthogonal axis generator. After that, you click to define the reference point. Just pick a reference point which is a bit far away from what you have imported. Like you look here. Like I'm choosing here. I will choose this point, and then you define the direction axis. So the axis label, we can keep it A and this one 1. So you can put the axis spacing of, let's say, 2 meters, 2000 times 3. Yes. Then down here, you can have 3000 times 3. You can place a comma if in case you are putting unequal spaces. Separate them with a comma. We can write maybe 1,500, comma 2,400. Okay. You click OK. You see, you have quickly created your center dimensions. So that is the second method. If in case you do not go into creating the DXL file, you can go with that method. Which one? But yes, it is the second, and I consider it the most accurate.
So those are figures of the beginning, those are the center.
Yes. Those figures, it meant that if like, for example, if I want to come up with a construction grid, the first 2000 times 3, it meant that this is 2000. This is 2000. And this is 2000. So for me to enter all these ones at once, I just type 2000 times 3. Then the other one has been, it was 3, is it 3000 times Okay, okay, just in case if this is 3,000, this is 3,000, and then this is 1.5, and this is 2.4. Okay, so for these ones, you type 3,000 times 2, comma, you put this, comma, and this. If in case you find that there is another division and still 2,400 times again, so you just times 2. And when you're recording those dimensions, you need to stick to this direction and also this direction. Don't put 2,000, comma, for it should be strictly from left to right. Even this other side should be strictly from bottom up to top, not coming from this center. You get it? Yeah. So along this direction, this is direction 1, D1. Then around this direction, D2. Yes. So after you have added your grid, it's now easy to create columns. Just come to column and then keep on pressing the columns. You click on column. Okay. You click on column. You provide now the section size of 200 by 200. You've seen where we place the section size? Just type it there. It is ready to up there. If it's not there, you type it there. B1, B2. So once you have put that section size, you just need to get the axis intersections where the columns are. Like at this point, okay, you keep on placing the columns. It's done. Okay, so we already have columns in our project. So this one I'm just doing it for just demonstration. Let's delete this first one. This upper one will remain with the one which we had created. Now, let's connect beams. Oh, before we connect beams, we need to name these grid lines. When I look at this architecture, so these ones have been named in alphabets. Then these are numbers. So let's do the same thing here. We select the first one. You double click on it. It gives you the properties palette. You change the label up here. If you double click on that grid, you should get this dialog box. It is red. You have double clicked on it. You have this dialog box. Double click and get this dialog box. That's why we are double click.
You see the legs and the arm.
Axis. Now, yes. One. Okay. So if I double click here, I'll change this to A, update to change. Double click, change it to B, to update to change. So now what I want is for us to change them all at once. You're going to click on the next. Hold down Control, select them in their order. Okay. This, and this. Then you right click on one that has been selected and then choose properties. Right click and choose properties. So in the properties, you now you see the way how you have selected the order. That is the same way they are able to. So what you now you want to do is anything. So this is C, D, E, F, G, you can even use the type C, shift the next one, then this. So that's so here this is going to be C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, Q, R, S, T, U, V, W, X. Okay, so the end of X. Once I'm done, I will close. Okay, so they have changed. You close. You have misplaced the name of the order. renaming them is the heat. Like we do now. So now let's rename this one. So you select them in order. You click on each, like select this one,
Then control.
control, select, 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 select. And then you can right click properties. Okay.
What is that? Anyway, what is it?
We are selecting that.
Which is overlapping the other one. The first set is A to the second, A and five. Oh, maybe
No delete, don't delete. Oh. Yes, So in the plan, that's what we have. Then you right click. Okay, you click on views, this side here. Click on views. It is this one side where the structure axis. You see, when you are in this structure, if you're not seeing anything, you click on these arrows. These arrows next to there. So have you seen views? views.
Yeah.
Right click on it. Then you go to 3D physical model. 3D physical model. Oh, right click. Oh. This one rotate. You right click and rotate. You can see your project at different angles. Those are the colors. So let's go back to plan. You see here, you have a plan and the 3D now. Plan, then 3D. You see this on these tabs here. You have two tabs. Okay. Story plan and then story 3D. You see, you choose plan. Okay. Now, you click on beam. Mm. You're going to draw, you put the cross section of a beam. You can have it as 200 by, let's say, 350. The depth here is h, 350. Okay. Three 350 done. Depth. So to draw the beam should be from axis intersection. Point there and see that show you axis intersection. You click to axis intersection. You right click to stay in command. Then you go to another position, axis intersection, axis intersection. Right click, you go to another position, axis intersection to axis intersection. So you continue to create those beams up to the last. Yeah.
This is the big one. Yeah, yeah. So I think this one will go. Yes, I want to leave this one. But it is really all first press escape. First press escape.
Now, you want to create more views, but you have already created one which has got properties. You create another, don't go back. Double click. The properties bar. Now, this simple section. Simple section. Right click. Close the button. Close the There's no right click to save the command. Then shift the other position. So you continue to press your back. First press escape. Now on the folder that I gave you, so that you will plus 5
First,
that's right. Yeah. So you are going to put all this. If there's where
this fluid.
For example, one organization start with that start with like this.
No, for example, this has no code, so if you don't click and stop.
Okay, you first draw this one. Yeah. Then come okay. Then come here.
I said you will send me the code because I need to Magica. Before we leave now,
The recording I'm going to give
all those steps.